Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Today we will discuss our lecture number 6. Course title is Advanced Physical Chemistry, course is Conductometry, and the course code is CHEM3117. I am Dr. Rana Farat Mahmood. Let us start our lecture. The contents of our lecture are: number 1, conductometric titrations; number 2, advantages and disadvantages of conductometric titrations; number 3, applications of conductometry. Okay, the contents are: number 1, conductometric titrations; number 2, advantages and disadvantages of conductometric titrations; and number 3, applications of conductometry. Let us start our lecture on slide number 4, that is conductometric titrations. Okay, conductometric titrations. First of all, we will discuss its introduction. It is a process of qualitative chemical analysis in which concentration of sample is determined, which is done by adding reagent means titrant of known concentration in measured values to the samples means analyte. Basically, conductometric titrations are the qualitative, means in this we check the quality of sample, not the quantity. Means we will check the quality of ions. Here we will discuss the types of conductometric titrations. The first type is acid base or neutral titrations, and second type is replacement or displacement titrations. In first type we will titrate any acid with a base, and in the second titrations we will titrate a positive ion with negative, means the replacement of ions will take place. And in the third type, this is redox titrations. This is the redox reactions. It means that we will use a reaction in which redox process will be occurring, and titrations will be also be occurring, so it is called redox titration. The fourth type is complexometric titrations. This titration is somehow complex. The fifth type, non-aqueous titrations. It is a reaction in which we will not use water. Let us go over slide number 6. The first type is acid base or neutral titrations. Acid base or neutral titrations are these titrations in which number 1 is strong acid and strong base, means that the strong base is titrated against the strong acid. Example is given: HCl, which is a strong acid, and it is titrated against NaOH, which is a strong base. Second is strong acid with weak base. The example given is HCl, which is a strong acid. It is titrated against the weak base, that is ammonium hydroxide NH4OH. The third is weak acid with a strong base. Example given is acetic acid CH3COOH is titrated against the strong base NaOH. One by one we will see their graph, and their graph will be discussed in the next slides. Okay, the fourth is weak acid with the weak base. Example given, the acetic acid CH3COOH, which is a weak acid, is titrated against the weak base, which is ammonium hydroxide NH4OH. Let us go our slide number 7 to discuss the strong acid with the strong base titration, acid base or neutral titration. This is our slide number 7, and on this slide number 7 we will discuss how strong acid is titrated against strong base, and as a result of this titration what we obtain. The first line is that fall in conductance, means there is a fall in the conductance. There is a fall in conductance, and this fall in the conductance is due to the replacement of high conductivity of hydrogen ions by the poor conductivity of sodium ions, because we have discussed earlier its example that HCl is titrated with NaOH, sodium hydroxide, and the hydrogen ion in the HCl are replaced, their high conductivity is replaced by the sodium ions. These two are positive ions, cations, so they replace each other. When replacement occurs, then hydrogen ions are replaced by sodium ions. As hydrogen ions have high conductivity and sodium ions have poor conductivity, when hydrogen ions are replaced by sodium ions, it means that the conductivity falls. There occurs a fall in the conductance, because high conductivity hydrogen ions are replaced by poor conductive sodium ions. Okay, the second line is that rise in conductance due to increase in hydroxyl ion concentration. Okay, the second one line is there is occurs a rise in the conductance. This rise in conductance is due to the increase in OH ion concentration. Okay, here is a graph of conductometric titrations of HCl versus NaOH, strong acid versus strong base. Okay, the red line graph is for HCl conductance, and HCl conductance we know that there is a fall, and the NaOH conductance there is an increase in the hydroxyl ion concentration, so there is an increase in the conductance. Okay, let us go on slide number 8. Strong acid versus weak base. When we titrate strong acid with a weak base, the example is HCl with the NH4OH. The result is that there is a fall in conductance. This fall is due to the replacement of hydrogen ions by ammonium ions. The hydrogen ions have high conductivity. These are replaced by ammonium ions. Ammonium ions have low conductivity. So there is a fall in conductance. Second line is conductance remains constant due to suppression due to falling of NH4OH by NH4Cl, means ammonium hydroxide suppressed and change in ammonium chloride. When this change occurs, then the conductance increases. When in the first line we have seen that there is a fall in conductance, and in the second line the conductance decreased, and as a result the conductance remains constant. Okay, graph line is the blue line rises from top to the blue line rises from bottom to top, and the red line falls from top to bottom, but in the middle the red line of HCl conductance slightly falls, and at the last it remains constant. It means that the conductance firstly falls, then remains constant. Okay, let us go on slide number 9. It is for weak acid and strong base. At initially there is a decrease in conductance, and then followed by increase, then increase due to NaOH, sodium hydroxide. Firstly decrease in conductance and then increase in conductance due to NaOH. Okay, the steep rise is due to excess of NaOH. If we see the graph line, we see the two graph lines. One is blue line and then is red line. Red line for CH3C double OH conductance, and it constantly it constantly falls from 30 to 20. And if we talk about x-axis concentration, at 20 concentration we see that two lines, blue and red, blue for NaOH conductance and red for acetic acid conductance. These two lines cross each other at 20 concentration on x-axis, and this point where these join together is basically the measurement of conductometric titration. Here one conductance means acetic acid conductance falls, and means acetic acid conductance falling, and NaOH, sodium hydroxide conductance rising. Okay, initially there is a steep decrease in the acetic acid conductance, and if we talk about NaOH conductance, then initially it is steep rise. Okay, this is due to the excess of NaOH, because NaOH is a strong base. So due to OH group, hydroxyl group, the conductance increases and goes to top of graph. In the case of weak acid and weak base, there is an increase in conductance which is due to excess of acetic acid, and conductance remains constant due to suppression of NH4OH by CH3COOH. Let us talk about graph. We have two lines. First is red line and then is blue line. The red line for acetic acid conductance, blue line for ammonium hydroxide conductance. The red line falls from 30 to almost 50, 15, and then it rises and then remains constant. In case of blue line ammonium hydroxide conductance, there is a steep increase from 10 to 20, and then it remains slightly constant, and then steep increase to 25. At a point O, where two lines cross each other on the graph, where arrowhead is mentioned, if we see on x-axis, then it becomes the concentration of 15. The amount of conductance here is same at their concentration. Concentration is 15 and the conductance of both acetic acid and ammonium hydroxide is the same on this concentration. So here from this point further we see that the ammonium hydroxide concentration increases and the acetic acid concentration remains constant. Now we will discuss the advantages of conductometric titrations. Many advantages of this conductometric titrations. Some of advantages are mentioned here. It does not require indicators. It don't require indicators, since change in conductance is measured by conductometer. Okay, the conductometer measures the change in conductance, so it does not require indicator, as we see that the other titrations require indicator such as phenolphthalein and potassium permanganate, but this conductometer titrations is measured by conductometer, not require any indicator. Okay, the second advantage is it is suitable for colored solution. The third advantage is that since endpoint is determined by graphical means, accurate results are obtained with minimum error. We have seen that each titration was discussed and its result endpoint was discussed by a graph, so their chances of error are minimum. And the fourth advantage is that these titrations are used for analysis of turbid solutions, weak acids, weak bases, mixture of weak and strong acids. Okay. Now, disadvantages of conductometric titrations. First disadvantage is that it is used for increased level of salts. There is a concept that increased level of salts in solutions mask means it lessens, means it reduces the conductivity changes. Okay, the change in conductivity is not measured accurately due to the increased level of salt in solutions. In such cases, it does not give accurate results. Okay, the conductometric titrations, the disadvantages, we are discussing the disadvantages of conductometric titration. The first disadvantage is that if there is a salt in solution, then conductometric titration does not give us accurate results of conductivity changes. The second disadvantage is that the application of conductometer titrations to redox systems is limited because high concentration of hydronium ions H3O positive ions in solution tends to mask. Mask mean to cover, to hide conductance changes. Okay, the hydronium ions and the high concentration of hydronium ions tends to cover to hide the conductance changes. So these applications of conductometric titrations to redox systems is limited. Why limited? Because sometimes we have the high concentration of hydronium ions. This high concentration of hydronium ions in the redox reactions uh, hides, covers, masks the changes in conductance. Now, where the applications of conductometry or where the conductometry can be applied. The conductometry, first application of conductometry is that first application is that we check the water pollution in river and lakes. It is the application of conductometry. Means in river and lakes, if there is a water pollution, it means that there are some ions in water. When there are some ions in water, if we do conductometric titrations, means if the water is acidic, then the graph line will show that the water is acidic. If water is basic, means some base is added in water, then graph line will show that water has some basic properties. Okay, these graph lines of conductometric titrations shows that the water is polluted or not. If there is no change in graph line, then we will say that water is pure, not polluted. Second thing is that it is used in alkalinity of fresh water. Basic mechanism which is used in this application is the application of conductometric titrations. Means that if fresh water has some alkalinity, it means that it has some basic properties, it has some base, and if we use a strong acid with a strong base, then the conductivity will be decreased because there will be hydrogen ions of water will be covered, will be masked by the sodium ions of the base alk oxide, means NaOH base. Okay, the third is to check the salinity of seawater. Okay, the seawater salinity means the saltness of seawater. We have said in the last slides that if there are some salt solution in our conductometric titrations, then the conductivity changes are not measured accurately. Okay, by checking the salinity, we will have a signal that our conductivity changes will not be measured accurately. Then we will say that the water is saline, means it has some salts. The fourth application is Deuterium ion concentration in water deuterium mixture means that it is used to check whether in water deuterium mixture the deuterium ion concentration, how much deuterium ion concentration is present. Fifth application is that it is used in food microbiology, means that for tracing microorganisms. The sixth application is that it is used in tracing antibiotics. Seventh application is that it is applied for estimating the ash content in sugar juices. And eighth application is that it is applied for checking the purity of distilled water and deionized water. The purity of distilled and deionized water is determined by application by applying conductometry or conductometric titration. So this was our lecture number 6 about conductometric titrations, advantages, disadvantages and their applications. Any question regarding this lecture you can ask. Allah Hafiz. Stay safe, stay blessed.